So in this video, we are going to continue our discussions from chapter number 7, triangles. So in this video, we are going to see different properties that exist for an isosceles triangle. Okay, but before we see what are the properties of isosceles triangle, let's understand the definition. Let's understand what is an isosceles triangle. So the definition of isosceles triangle is very simple. Now consider this triangle. Okay, I would draw an example. Okay, so in this triangle, if any two sides are equal to each other, let's say I'm going to say this side is equal to this side. Okay, I'm going to name the triangle. Let's call it A, B, C. So in triangle ABC, if any two sides, okay, AB and AC are equal to each other, then the triangle is called as isosceles triangle. As simple as that. Now let's try to draw another example of the isosceles triangle. So I'm going to draw it here. So let's say this is one side, okay, and this is one side, okay, and let's say this side is equal to this side, okay, and I'll also connect this side, okay. So in this triangle, okay, in this triangle, let's name it PQR. PQR. In triangle PQR, you can see PQ is equal to QR. Okay, any two sides of a triangle are equal to each other, then that triangle is called as an isosceles triangle. So that's it. That's simple, straightforward definition of what is an isosceles triangle. So I'm just going to write it here: a triangle, okay, in which any two sides are equal to each other. Okay, that triangle is called as an isosceles triangle. Now, with isosceles triangle, we have some important property or some important characteristics that they show. Now, first of all, this is the first one. It's a theorem, so let's read it out. Angles opposite to equal sides of isosceles triangle are equal. Okay, what does this theorem mean? Let's try to visualize it. First, let us draw an isosceles triangle. So something like this. Okay, so in this triangle, I'm going to have this side as equal to this side. Let's name the triangle. Let's call this triangle A, B, C. Okay, so is this an isosceles triangle? Yes, as per the definition that we saw just now, this is definitely an isosceles triangle because two sides are equal to each other. Now, what does this theorem say? Angles opposite to equal sides. So these are the two equal sides. The angle opposite to this side AB is this angle. So I'm just going to use a highlighter. Okay, this angle, and the angle opposite to this equal side AC is this angle, angle B. Okay, so angle B and angle C are the opposite angles to the equal sides. Okay, so that's what the theorem is focusing on. Angles which are opposite to equal sides of isosceles triangle are equal. So the theorem says that angle B is equal to angle C. These two angles which are opposite to the equal sides are equal in measure. Now, since this is a theorem, let's see how we can prove it. So let's try to zoom in into this triangle. Now I want to run construction in this triangle. So in triangle ABC, okay, first of all, let's remove the highlighted thing. Okay. So this okay. So we have side AB as equal to side AC. Now let us construct. So I'm going to use, yeah. So let us construct an angle bisector of angle A. Okay, what I'm going to construct is, so let's name it. Let's call this as Q. Okay, so AQ. What is AQ? AQ is an angle bisector of this angle A, which means, let's in fact zoom in, which means that this angle, okay, is equal to this angle. Okay, so that's our first point. I'm trying to zoom out now. Okay, so point number one, construct angle bisector. Okay, construct angle bisector of angle A. Okay, so angle BAQ, okay, this angle BAQ will be equal to CAQ. Okay, so angle BAQ will be equal to angle CAQ. Okay, this is important. This is by the construction because it's an angle bisector. Now if you look at this triangle, yes. So now point number 2. Okay. Now focus on this triangle ABQ and triangle ACQ. Okay. So in these two triangles, we have this side equal to this side. We have this angle equal to this angle, and we have the side AQ, which is common to both the triangles. So by side angle side test, SAS, this angle is included between the two sides. By the SAS test of congruency, this triangle is equal to this triangle. And once we prove that these two triangles are congruent to each other, then all the three sides and all the three angles of the triangle will also be congruent to each other, which means this angle B will be equal to angle C. So that is the approach in proving this theorem. So next point that I want to write is, okay, so consider triangle ABQ and triangle ACQ, triangle ABQ and triangle ACQ. So in these two triangles, the first point is AB is equal to AC. Why? Because it's a given. I mean, it's an isosceles triangle, so side AB is equal to side AC. And then the second point is angle BAQ is equal to angle CAQ. Why? This is from statement number 1. Okay, because we constructed the angle bisector. And the third point is side AQ is equal to side AQ. Okay, because it's the same side for both the triangles. So thus, now I'm going to move it here. Yes. So thus, from these 3 points, we can say, thus, from SAS test of congruency, SAS test of congruency, we can say triangle ABQ is congruent to triangle ACQ. Okay, this is the important part. Triangle ABQ is congruent to triangle ACQ. So, and from this statement, we can deduce, or we can confidently say that angle ABQ, yes, angle ABQ is equal to angle ACQ. Correct? Because those are the congruent angles of the congruent triangles. Which means, now let's use the highlighter, this angle is equal to this angle. And thus we have proven this theorem. Sorry. Thus we have proven this theorem which says that if the sides of two triangles are equal, then the opposite angles to the equal sides are also equal to each other. So this theorem is proved. Now similar to this theorem, we have the converse theorem for an isosceles triangle, okay, which we are going to prove in the next part now. So okay, so I'm just going to copy paste this. Copy. So the converse of above theorem is also true. Let's see how that turns out to be. Okay. Now in the converse theorem, okay, in the converse theorem, what we are going to have is sides opposite to the angles. Okay. So let's come here first. So equal sides were given to us. We proved that the opposite angles are equal to each other. Now in the converse theorem, we will say the angles are equal to each other, and we have to prove that these two sides are equal to each other. So let's come down. First of all, let's change the statement. So I'm going to say sides. Okay. So I'm going to strike this angles, and I'm going to say sides opposite to the equal angles. So equal angles, okay, of the isosceles triangle are equal. Okay. So again, the way we prove this theorem is very much similar to the previous approach. So this is my triangle, okay, and the given thing is this angle, okay, is equal to this angle. Oops. Okay, this angle is equal to this angle, and let's name this triangle first. Let's try to zoom in. Yes, so this triangle, let's call it ABC. In triangle ABC, we have this angle as equal to this angle. Once again, we are going to construct a angle bisector from here. So this is my angle bisector. What is the property of the angle bisector? That it will create the this angle as equal to this angle. Okay, because it's an angle bisector. Now, once again, if you okay, we have not named this point. Let's name this point as equal to Q once again. Okay, now once again, focus on this triangle and this triangle. In these two triangles, we have this angle equal to this angle equal to this angle, and this side AQ is common to both the triangles. So by AAS test, okay, angle side test, we can prove that this triangle is equal to this triangle. Okay, so once again, okay, first of all, we are going to write down the construction part. So point number one, construct an angle bisector, okay, angle bisector of angle A. Okay, therefore, angle BAQ is equal to angle CAQ. Okay, yes. Now, point number two, in triangle ABQ and triangle ACQ, point number one, we have yes, so we have angle BAQ as equal to angle CAQ from statement number one. Then secondly, we have angle B, okay, let's write it, angle ABQ as equal to angle ACQ, okay, because this is given. And the third thing is side, okay, side AQ is equal to obviously side AQ because they are the same sides of the two triangles. Okay, however, the test of congruence is different. That is the thing that we have to understand as compared to the previous one. So okay, so I'm going to write here using angle side test of congruency, we can say that triangle ABQ is congruent to triangle ACQ. Okay, and once we prove that this triangle is congruent to this triangle, then all the three sides of the triangle and all the three angles of the triangle are congruent to each other. So now we can very confidently say, therefore, okay, side AB. So let's use a highlighter to understand. This side AB is equal to this side AC in the triangle. So side AB is equal to side AC. Okay, and what are these sides AB and AC? If we come to this triangle, these sides AB, so this is that side AB and this is that side AC, which are equal to each other. But most importantly, these two sides are the opposite sides to the congruent triangles, congruent angles. Okay, so thus we have proved the converse of Abbo theorem, okay, which says that sides opposite to equal angles of isosceles triangle are equal. So these sides are equal if the angles are equal, and the Abbo theorem was if the sides are equal, then the angles are also equal. So this is an important property of an isosceles triangle, and using this property we can prove a lot of theorems and we can solve a lot of problems in the next exercise, which is wholly and solely based on these two simple properties of isosceles triangle.